Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 9.1, exploring combinations of functions. Now this unit, guys, a lot of people, get really confused in this unit. A lot of the questions that are derived from this unit end up becoming thinking questions on your unit test. Now, some teachers do it differently. They may have a subunit that's just talking about this, but I want to just go over, the main concepts with regards to combinations of functions. So I wrote it out here. Now, there are four different ways you can combine different functions. One way is you add them. The next way is you subtract them. The third way is you multiply them. And the fourth way is you divide them. Okay? Now, it's important to know the notation because a lot of students that I've taught, they just see the question, but they don't know what it's asking. Okay? If you're talking about adding two functions, you are literally adding two functions. But here's the thing, sometimes in the textbook, it may show you the form being like this. So if you see f plus g in brackets and multiplied by x, you should know that that is the same thing as you saying f at x plus g at x. In the same way, for subtraction, it's the exact same thing. You'll have f at x minus g at x, and that's the same thing as saying f at x minus g at x. For multiplication, you have the same thing over here. It's just two functions being multiplied by each other. And for division, we got two functions being divided by each other, hence why it will look like this in the notation or this in the notation. Now, an important thing to consider when you're doing these kinds of questions is sometimes when you're doing these kinds of questions, they will ask you to either show this graphically or they will ask you to show this algebraically. Okay? And you need to know how to do it in both ways. Okay? Graphically, how do you add two functions? If they give you two graphs of two different functions, how do you find the f at x plus g at x graph? By graphing it. So with graphically, they may ask you to use a table of values. Now, algebraically is a lot easier in my opinion because it's kind of like adding polynomial functions or adding, whatever functions together or subtracting them, multiplying them. There's a lot of algebra, right? That's why we say algebraically. There's a lot of algebra. So when you're doing it algebraically, it's a little bit easier, but you're going to be asked to do both. Okay, now it's important if you have a teacher, just ask them on the test, would you want me to do it graphically or would you want me to do it algebraically? It should say in the question, but sometimes they don't say, so they give you the choice. The next thing that I want to talk to you guys about is composition of functions. So the first part is combining functions. So this is called combining functions. Okay? So you're taking two functions and you're combining them together, either adding, subtracting, multiplying, or dividing. Composition of functions is a little different. The word composition, right, it's almost like what is a function made up of? What is it composed of, right? What is the composition of it? So here's where this other notation comes in. If you ever see this notation where it says f dot g at x, this is the same thing as saying f of g of x, okay? Now, what does this mean? This means that we're literally taking g of x and we're plugging it into the function of f at x, okay? This is a very interesting concept. And I want you to think of the g at x as the baby and the f of x as the parent. Or you can even think of it as the mother. The baby is within the mother, okay? So for example, if they gave you a question like this, f at x is equal to 2x plus 5, and then they said g of x is equal to 3x squared, what we would be doing is we would be taking this 3x squared and we would be plugging it in as x. So then f of g of x would be 3x squared plus 5, which gives you 6x squared plus 5. So you see how we're putting the baby in the mother, okay? And that's a great way of understanding these types of questions. In the same respect, we have g of f at x, right? Also known as g bracket f at x, where in this case, it's just flipped. The f at x becomes the baby, and the g of x becomes the mother, right? So if we were to take f at x and plug it into g at x, this is how that would look like. We would be plugging the 2x plus 5 into the 3x squared. So it would be 3 bracket 2x plus 5 squared. So you see how we took the f at x and plugged it in here. So here we have 2x plus 5, and then we would simplify it. So we got 3, 4x squared plus 10x, so plus 20x plus 25. And then we would expand this out, so we'd have 12x squared plus 60x plus 75. Okay? So composition of functions are very different. It's putting a function within another function, right? Either putting f at x within g at x or g at x within f at x. Combinations of functions are using orders of operations within functions. So either adding them, subtracting them, multiplying them, or dividing them, and we're doing this either graphically, using a table of values, or algebraically. So I hope this video meant a lot to you guys, and I hope you guys understand the basic concepts. Feel free to follow, subscribe for more videos like this. We post every every week from Monday to Friday at 3 p.m. Eastern. And if you're somebody who needs tutoring, feel free to click the link in our description, and our team would love to get in touch with you to help you with advanced functions. But without further ado, I'll see you guys in the next video.